So next topic is covalent bond. So already we seen ionic bond. So in ionic bond, transfer of electron takes place. So transfer of electrons from one atom to another atom, it is permanently electrons are transferred to attain stable configuration. Next topic is covalent bond. So in this topic, same example you take. Suppose two different atoms A and B combine to form AB. Previously we seen ionic bond A plus B combined to form AB. In this, electrons from one atom permanently transferred to the another atom to form AB. In this case, slightly differ. Suppose A atom contains one electron, B atom contains one electron. For differentiating, I put cross and dot because these are two different atoms. So for differentiating these electrons, I use cross for A and dot for B. So these two different atoms, these two atoms contains one electron each. These electrons are contribute with each other to form AB. So these one electrons of both the atoms are contribute with each other to form AB. How this molecule is formed? I said these electrons are contribute to each other to form a molecule AB. In this, these two electrons are contribute to each other to form a pair of electron. To form a pair of electron. So based on this, you see, to form a pair of electron in which both the atoms attains stable electronic configuration. Stable means already I mentioned either it is duplet or octet. So both the atoms attains stable electronic configuration. Maybe a duplet or it may be octet. You check alone A ring. So only you check with the A ring, two electrons are there. When you check with the B ring, two electrons are there. So in this case, sharing of electron takes place. These both electrons are shared to form a molecule in which the electrons are paired. Also, the compound formed in which both the atoms attain stable electronic configuration. So, based on this, covalent bond is defined as any molecule sharing of electron takes place between the atoms to attain stable electronic configuration. So covalent bond is defined as, so any molecule sharing of electrons takes place between the two atoms to attain stable electronic configuration. So, I said these two atoms are contribute with each other to form a electron pair. If it is single electron pair, means results in the formation of single bond. That's why I mentioned single line. The single line denotes single bond. Single line denotes single bond. If it is two electron pair, results in the formation of double line or double bond. So double line means meaning is double bond is present. If it is three electron pair, results in the formation of triple bond. So there's triple bond. So always remember, if it is single electron pair, that is one pair means it is single bond. If it is two pairs of electron, that is two electron pair means double bond. If it is three electron pair means triple bond. So let's see some examples of covalent bond. So first one they given in the textbook. You will see each example for single, double and triple bond first. First one we will see for single bond. So hydrogen molecule. So hydrogen molecule means two atoms of hydrogen combine to form a hydrogen molecule. That means H plus H combine to form H2. So obviously we know hydrogen is the first element, so atomic number is 1. So K shell contains 1 electron. So this electron is an outermost electron. In this case we have to see the valence electron only. We have to see the outermost electron, that is valence electron. So hydrogen valence electron is 1. So I am mentioning both the atoms as dot because they are same molecule, that's why I put dot. So in this case these two combine to form an hydrogen molecule in which they share two electrons. These two atoms, these electrons of this atom contribute to each other to form an electron pair. You see it is a single electron pair, so we have to mention single line, that is single bond. Because of one pair we mention one line, that is single bond. Let's see for next one. Next is oxygen molecule. So oxygen molecule means two atoms of oxygen combine to form an oxygen molecule. Oxygen atomic number 8. When you put Bohr's model, K shell contains 2 electrons. So maximum you have to fill only 2 electrons. Out of 8, 2 electrons filled means balance 6 in the outermost electron. So you have to see only this outermost electron. No need to see the electrons present further inside. So you have to see only the valence electron of an atom. So in this case, oxygen is, this is oxygen plus, so they have 6 valence electron, 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. These two combine to form an oxygen molecule. You see, this atom contains 6 electron. This is also contains 6 electron. So I said once a molecule is found, both the atoms should attain stable electronic configuration. For this oxygen to attain stable configuration of octet, octet means 8, so need 2 electron. So this atom, this oxygen need 2 electron and this oxygen need 2 electrons. So total number of electron you count. This oxygen need 2 electrons to attain octet. This oxygen also need 2 electrons to attain octet. Total 4 electrons. So in between there are 4 electrons are shared. 1, 2, that means 2 pairs. So already these 2 electrons shared, so total 4. So out of this 2 electrons shared means balance we have only 4. So once again I am telling, this oxygen is 6, this oxygen is 6, so need 2 more electrons to attain octet. So this oxygen 2 electron, this oxygen 2 electron, so total 4 electrons are shared, that is 2 pairs. So out of this, from this oxygen 2 electron, this oxygen 2 electron. If these 2 electrons are shared means remaining you have 4 electrons in the outermost shell. 1, 2, 3, 4. Same way for these 2 electrons are shared, so balance 4 electrons in the outermost shell. So in between oxygen, you see the individual ring of oxygen and count the number of electrons, comes as 8. 1, 2, 3, 4. So in between shared 4 electrons, so 8. Same way you check with this oxygen ring. So 2, 4, 6, 8. So this oxygen also attain stable electronic configuration of octet. But in this case, you see the number of electrons per share. Already he said if it is 1 electron per single bond, in this case 2 electron per, so it is double bond. That means O, double bond O. because of 2 electron per double bond or double line. So next one is nitrogen molecule, and this nitrogen atomic number is 7. So K shell 2 electron, L shell 5 electron, because out of 7 2 electrons will balance 5 in the outermost shell, so you have to see only the outermost shell. So nitrogen, so valence electron is 5, so 1 2 3 4 5, 1 2 3 4 5. Same way you will see. So this nitrogen contains 5. This nitrogen contains 5 valence electron. For this hydrogen to attain stable electronic configuration of octet. So this atoms to attain 8 electrons means need 3. For this atom, this nitrogen also need 3 electrons to attain 8. So total 3 plus 3, 6. So this 6 electron pair. 6 electrons means 3 pairs. So 1, 2, 3. Because of 6 electron, 3 pairs. So same way, in this 3 electrons are shared. From this nitrogen, 3 electrons are shared means remaining 2 in the outermost. Same way for this hydrogen, these 3 electrons are shared, so we have balanced 2 electrons. You check with individual nitrogen. So for suppose you check this ring alone, if you check means, so already they shared 6 plus 2, 8. Same way for this nitrogen alone, you check, it contains 8 electrons. So both the atoms attain stable electronic configuration of octet. But in this case, there are 3 electron pairs. So 3 electron pairs means triple link, that is triple bond. So N, triple bond, N. That's why they are mentioning bond in between the atoms. If it is one bond means there is 1 electron pair. If it is 2 double bond, 2 double line means double bond, that is 2 electron pair. If it is 3 line means triple bond or 3 electron pair. Same way you try for NS3. You try for NS3. Ready for CH4. It is given in the textbook. So carbon atomic number is 6, so 2, 4, so you have to see, you have to count only the valence electron. Hydrogen atomic number is 1, so K shell is 1, so you have to see this outermost electron. So there are 4 hydrogen. There are 4 hydrogen and 1 carbon. 4 hydrogen and 1 carbon. But this hydrogen valence electron is 1, so each atom contains 1 valence electron. Carbon valence electron 4, 1, 2, 3, 4. So for differentiating, I put cross and dot. Whenever you do this covalent bond structure, always you see if it is same atoms, is okay, no problem. If different atoms, you have to differentiate the electrons. Suppose that's why you put hydrogen for dot, carbon for cross. It's your wish whether you put a cross for hydrogen and dot for carbon. So you check. Now see the molecules. Carbon valence electron is 4. So need 4 electrons to attain 8. That is octet configuration. And you see hydrogen valence electron is 1. So each atom need to stable electronic configuration of octet need 1 electron, that is 2. So this hydrogen, so already valence electron is 1. To attain stable configuration of duplet need 1 electron. This carbon need 4 electron. So this 4 hydrogen shared with 4 carbons, the 4 electrons present in the carbon. Once again I am telling, this 4 carbon and this 4 valence electron in the carbon shared by 4 hydrogen. So carbon 4 electrons are shared with 4 hydrogen. This 4 electron I put cross, and hydrogen obviously I put dot. horizontal hydrogen. Now you see each individual hydrogen attain duplet configuration. Any hydrogen you see, any ring of hydrogen you see, two electrons, so attains duplet. You see the carbon ring alone. Inside the carbon ring you see 2, 4, 6, 8. So molecules attains each both the atoms present in the molecules attains stable electronic configuration of octet. Same way you try for nitrogen. Nitrogen atomic number already we know 7. So outermost 2, 5 we have to see the valence electron. Same way for hydrogen atomic number is 1. So this is the valence electron. You try for ammonia molecule. So that's all about covalent bond. So next we will see characteristics of covalent bond.